In my previous video, I brought up the problem of large data sets in statistics. Very often we get so much data that trying to take in all of the data at a single glance is just too much. You can't really get a sense of the numbers by looking at all of them at the same time. There's too many. What we really need is some sort of a single score that can give us a typical value for all of the scores that we see here or in data sets that are larger than this. And so that single score we call a measure of central tendency. And the one that I'm going to discuss, there's a few of these. We brought these up in the last video as well. The mean, the median, and the mode. The one that I'm going to focus on in this video is the mean. Now the mean is probably, well actually, the mean is definitely the most important measure of central tendency that you're going to come across in this course. You're going to find that the mean is used far more often than the median or the mode in the upcoming chapters, all the way through to your final exam. And not only is it the most important measure of central tendency, it's also likely to be the most familiar. And I say that even if you don't know, knowing that you might not actually know the term the mean. You may not have heard that term before, but the mean is really just another name for what is commonly referred to as the average. And so if you understand what an average is, then you'll know exactly what the mean is. And the idea there is that an average is very simply just a total. So a total of all of your values, of all of your observations, over the number of values or observations that went into making up that total. So let's take an example. Let's say you work at a job where you wait on tables and you get tips at a restaurant throughout the week. So we've got Monday, Tuesday, Wednesday, Thursday, and Friday. Those are the days that you work. Now, for this particular week, maybe on Monday you made a very small amount in tips. You made $20. But that's all right, because Tuesday is movie night and the restaurant is right next to a theater, and so you pick up $120 in tips. So it's not looking so bad. Wednesday, it's back to a slow crowd, $30 in tips. Thursday starts to pick back up again, and finally Friday, it's a busy night, you make $180. So you've made quite a few different amounts of money throughout the week in tips. And if you wanted to try and figure out going forward, based on this 1 week of work, what you can expect or what would be typical for any particular day of the weeks that are coming up, what you could do is you could find the average. And the average, like I said, is simply just taking the total of all of your values and then dividing by the number of values. Here we have 1, 2, 3, 4, 5 different values, so we're going to have a 5 in the denominator. And to get the numerator, to get the top of the fraction, to get our total, we just have to add up 20 plus 120 and so on. So let's do that. Okay, so I've got 20 plus 120 plus 30 plus 50 plus 180, and that gives me 400. Okay, so my average, which is also called the mean is equals to 400 over 5 values that went into making up that 400. So the mean is 400 divided by 5. That's $80. So we make, on average, $80 per day. That's what we get as a summarizing single value, a single value that gives us the typical amount that we make per day. So pretty straightforward. It's just the way you would normally think about an average. You just take a total of all of the values divided by the number of values that went into it. There's only one more thing that I need to say before we're finished with introducing the mean, and that's that there's going to be two different versions of the formula. Now here I wrote out that the mean, or the average, is just equals to the total over the number of values that went into making up that total. But this is more formally written in two different ways, depending on whether your data is a population, or if you've measured the entire population, or just a sample. For a population, the symbol for the mean is mu. It's the Greek letter mu. It looks kind of like a funny M or a U with a tail on the front. Mu, or the mean, the population mean, is equals to the sum of all of your data values, so the sum of x, over the number of the population size, which is large N. So if you had a population of, let's say, 100, then you would need to have the sum of all 100 values in your population. If you had a population size of 5, then you would only need to have a total of your 5 observations, or your five values in the population on the top. The sample is the same basic structure of a formula, but now instead of using mu, we use capital M. They explain in your textbook that most textbooks use X bar. In fact, I'm used to using X bar to mean the sample mean, and so I might slip up sometimes throughout my videos and call the sample mean X bar. My apologies in advance. In your course, it's capital M. Capital M, or the sample mean, is equals to, once again, the sum of all of your observations, this time from your sample, and now it's going to be divided by the sample size. So these are the two different formulas that you're going to need going forward. You've got your population mean and your sample mean.